Just like every function family, the absolute value function family has a parent function, where the parent function is the simplest version of that function family that shares the shape of the entire function family. In this case, every absolute value graph is shaped like a V. That is a V. So the parent function is the simplest absolute value function that is shaped like a V. When we make the table of the absolute value parent function, we take the absolute value of each input. So the absolute value of -3 is just 3. The absolute value of -2 is +2. The distance -1 is from 0 is +1, so the absolute value of -1 is 1. 0 is 0 units from 0. And then when we're looking at positive inputs, the input and output are the same. For example, 3 is 3 units from 0, so the absolute value of 3 is just +3. We can graph the parent function by graphing these points. -3, 3, -2, 2, -1, +1, 0, 0, 1, 1, 2, 2, and 3, 3. If we look at this graph, the left branch, this left branch has a slope of -1. When x increases by 1, y goes down by 1. Alternatively, we can think of this as rise over run, rise of -1, run of 1 gives us a slope of -1. The right branch has a slope of +1, up 1 over 1, rise of 1, run of 1. When x increases by 1, y increases by 1. So here is my V-shaped graph. This is my graph of my parent function, including arrows indicating that this pattern continues with that slope of +1 for the right branch, the slope of -1 for the left branch. Oh, what happened here? -1, +1. The vertex is the turning point of the graph. The vertex is right here for the parent function, and it has a coordinate of 0, 0. The vertex of the parent function of the absolute value function family is the origin, 0, 0. The line of symmetry is a vertical line that divides the graph into 2 mirror image halves. Well, that is not very straight. Here is my line of symmetry. So if we look at this line and think of it as a mirror, the right branch is the mirror image of the left branch and vice versa. So every point on the right branch has a mirror image on the left side. So 3 units to the right of the line of symmetry, for example, has a mirror image point 3 units to the left of the line of symmetry. The equation of this line is just x equals 0. That is the equation of the y-axis. Every point on this line has a y-coordinate of 0. The domain of the absolute value parent function is all real numbers. This line goes forever to the left toward -infinity and forever to the right toward +infinity. The range, however, is not all real numbers. There are no negative outputs of the absolute value parent function. So there is 1 point on the line with an output of 0, 2 points on the line with an output of 1, a y value of 2, 2 points with a y value of 3, 2 points with a y value of 4.5. So every y value greater than or equal to 0 has at least 1 point on the graph, meaning the range is y is greater than or equal to 0. This is not the range of every absolute value function. This is the range of the absolute value parent function. Did I ever refer to the equation? The equation of the absolute value parent function is f of x equals the absolute value of x. This is similar to our parent function of our linear function family. It's the simplest version. We're not multiplying by anything. We're not subtracting or adding anything inside the absolute value bars. We're not adding anything on the outside. This is the untransformed, simplest version of the absolute value function.